I decided to do problem 9-2B, number 11. The problem looks like this. So just so you get an overview of what I'm talking about while I'm doing the problem. So the first part of the question, there's 4 parts, is A, says what is the total area of the board? That's a pretty way to solve it. Area equals base times height. The base of that board is a 10 by 10, so you'd simply do 10 times 10, which gives you 100. So the total area is 10. We're going to use that for problems B through D, which is why it was important to get that right away. So part B is what is the probability of the event of a dart landing on each lettered region of the board? So there are 5 regions that it could land on. They go from A, B, C, D, and E. And all of them can be out of 100, or they can all be reduced down. For my purposes, I'm going to leave them in 100 so that I make the other problems easier. So A, there are 4 shaded squares. So that one's pretty simple right away. It's 4 out of 100. If I look back at the problem, just so I can show you guys as well, I looked here, and there are 4 squares, which is why I said it's 4 out of 100. So next we do B. The square is a 4 by 4. However, we know that there's 4 shaded. You can either do it mathematically or you can count them. I'm doing it mathematically just so I can make it easier to show what I'm doing. 16 minus 4 is 12, which makes it 12 out of 100. Then we look back at the square here, and we notice that this one is at 1, 2, 3, 4, 5, 6. It's a 6 by 6, a 36 area square. However, we have to subtract 36 by the 16. So if we do 36 minus 16, we get 20. 20 over 100. Then we go back to the square once again, and we notice that this is an 8 by 8. Okay, 8 times 8 is 64. Minus 36, we get 28. So we get 28 out of 100. And then we have the last part, E, which is on the outer layer, and we already knew that it was 10 down and 10 across. So we know it's out of 100. We take our previous 64 and we subtract it, and we get 36. 36 out of 100. To check your work, you could always take these all and add them back up to make sure they equal 100. So part C, and these are the probabilities. Of course, they can all be reduced down. However, to make C and D easier, I am not reducing them down. But they all do reduce down pretty nicely. C says, if 2 darts are tossed, what is the probability of the event scoring 20 points? So on this problem, they gave us the chart of points. We can automatically cancel out B, C, D, and E, because no matter what combination of those 4 numbers, you will not be able to get 20. So the only option is A. So we know because of this square, there are 4 squares out of 100, or how we previously found out that there's 4 out of 100. We just simply have to write it down, and our first toss is 4 out of 100. Our second toss is the exact same thing, 4 out of 100. The probability doesn't change just because you're doing 2 tosses. The probability does not change. This can also be written as 4 out of 100 squared. This is actually, if you wanted to do the math, which you would want to reduce it down, it would be 16 over 10,000, or 1 over 623, which is that ultimate probability of scoring 20 points. So again, how I did that was I knew that A, because of up here, the probability of getting A was 4 out of 100. You're doing 2 tosses for A, so you have the probability of 4 out of 100 twice, which makes it why I said squared. You would multiply that out, and you'd ultimately get 1 out of 623. So for D, the last part of this problem, it says, what is the probability of the event that a dart will land on neither D nor E? So the probability that it won't land on here and it won't land on here. So we go back to our problem and we see where D is and E. I dotted them so I didn't have to look too hard to find them. What I would do first is, I know that the first one's 36, E is 36, D is 28. That gets me a total of 64. Now that's saying that you would want to hit those. So we want that it doesn't land on D or E, so we want A, B, and C. You can take it and take 100 minus 64, which will get you 36. So it would be 36 out of 100 chance, probability, that it will land on A, B, C, and not D and E. Another way you could do this is simply by adding 20 plus 12 plus 4. I did it with subtraction and addition. The equation that I used would be entire board minus D plus E equals 36. So again, that's where I got the 100 minus 36 plus 28 gets me that. And there's my work once again.